In my last couple of videos, we dealt with numerical expressions and evaluating them. We're going to be dealing in this video with variable expressions and variables. So let's start by defining what we mean by variable. Of course, the root word of variable, okay, we want to just kind of recognize here is vary, okay, and to vary is to change. So when we talk about a variable, we say it's a letter used to represent one or more numbers. You know, we could have a variable, say h, that represents, say, the height of a random person that we pull out of a crowd. Or we could say we have a variable a that represents the amount of money that I make in a given pay period or something like that, okay? And these things, they could change depending upon certain factors that go into play, like say the amount of money I make would be dependent upon how many hours I work, or the height of a person would depend upon, say, for example, loosely upon their age to a certain extent out of a crowd. So we're going to be using variables all the time, but we say any thing that we use a letter for that represents a number, one or more numbers, we're going to call it a variable. Okay, and I note here it says any number used to replace a variable is the value of the variable. So say for instance I had some equation here. It said the amount of money I make, A, is equal to $5 times the number of hours I work. Okay, we could say let H equal 5 hours, okay? And what we would do is we would say that this right here is a value for this variable. So we say the value of a variable is a specific thing that we could actually go plug back in. And when we do actually plug this back in, what we're doing is actually saying we are evaluating. So 5 hours, so we would get, say, 25 hours total here would be the amount if we worked 5 hours in a hypothetical. But we say what we just did here was we evaluated the expression. When we talk about evaluating an expression, we're talking about plugging in specific values for variables in our variable expression. Okay, but we say any expression involving variables, call it a variable expression, essentially. All right. We say when the variables in an algebraic expression are replaced by numbers, as we did over here, we're evaluating the expression. So we so use this term again here, and the result's called the value of the expression. So this final thing here is also referred to as some value. Okay. So when we talk about evaluating algebraic expressions, what we're doing is essentially this down here, and I've written it out in order. One, we write the algebraic expression with the variables. A lot of the time we're talking about a situation. So say for instance I'm trying to describe my paycheck, and we could talk about this as a verbal model. We say, well, my paycheck would be equal to $5 times however many hours I work. But the first thing we would do is we'd write the algebraic expression with variables. Now we're going to be looking at algebraic expressions over here that are already given to us. But again, we might write our own, okay? But once we look at these expressions, you'll notice this first one here, it says evaluate or plug in, okay, for this expression, this value here, okay? So what I want to do is plug this value in everywhere I see the variable in the expression here, and we're going to evaluate it and kind of solve it down to one simple value, okay? And that's what our second step here basically says. Substitute the values in for the variables and then simplify using the order of operations. So looking at this first example just really quickly here, I'm going to make a suggestion, and it's always this. When you evaluate, okay, we're going to replace all variables that we're evaluating for with blank parentheses. So we say replace variables first with blank parentheses. And this is just a personal thing. But I'll tell you what, if you watch my last video on order of operations, you can put parentheses around anything, and this is a good time to do it if you want to help you out with the order of operations. So in this first expression, we have this. We have -3 times x squared minus 5 times x plus 7. You'll notice here that instantly what I've done is I've just taken out every instance of x that we had here, because what we're going to do is we're going to replace it with this value. X is 2. This is our value here. So we want to evaluate this expression by substituting this value in to this expression, this incomplete thought, and then evaluating it using the order of operations. So for instance here, we would say order of operations, grouping first. We notice that there's nothing to do in the parentheses. Next, it looks like exponents. We say 2 squared, which is 2 times 2. We say that would be 4. And then we could rewrite the whole rest of this expression if we felt uncomfortable doing, say, this next in our heads, but we could have. We say this is -12 here. We'll do our multiplication next from left to right here. So -12 minus, we still have a minus here, and it looks like we get 5 times 2 is 10. Oops, we'll put in this color here, plus 7. And then we'll do our addition and subtraction from left to right. In order of operations, keep in mind we say addition and subtraction, but from left to right. So that doesn't mean we have to do our addition first just because PEMDAS says it comes first. We'll do this from left to right. So we say -12 take away 10 more would be -22, and we still have this plus 7 that we'll carry down here. -22 plus 7 would be a -15. So we'd say this is the final value on our expression after we've evaluated the expression for the value of 2 plugged in. Okay, so this next one here, we say 2 times the base plus 2 times the height. This is, if you're familiar with, like, say, a rectangle, this is actually the, or say 2 times the length plus 2 times the width, we say the base and the height. This is actually the expression for the perimeter of a rectangle. But say I want to find the perimeter of the rectangle when the base is 4 centimeters and the height's 10 centimeters. So we say, okay, well, first things first, just as we did last time, we use the darker color here. Since we're plugging in for both B and H here, we're plugging in 4 centimeters for B, so we say this would be 4, again, let's use the darker color here, huh? 4 centimeters for B, and then 10 centimeters for H. Sorry about the handwriting here, but I mean, this is a pretty simple one to evaluate here. We say 2 times 4 centimeters would be 8 centimeters, keeping in mind our units. Plus 2 times 10 centimeters, we'll do our multiplication first, is 20 centimeters. And of course, centimeters plus centimeter, we're going to get centimeters, so we say 28 centimeters is the final value. And then last but not least, we have the area of a trapezoid, which looks, you know, intimidating, but it's basically just saying, hey, look, I'm some algebraic expression, and we're going to plug in these values into it for the appropriate spots. Okay. So one thing I want to say about evaluating before we finish this video is this. It is simply plug and chug. Okay. You'll hear this expression sometimes maybe, or at least I use it, plug and chug. And we'll do this a lot of the time. So we say 1/2, we have base 1 plus base 2. I'm going to get that a little bit closer, times the height. And, you know, sometimes I get people that lightly say in pencil, they'll put in the variable values underneath so they know where it goes, kind of like Mad Libs or something like that. So we say, all right, so B1, we have 20 inches. I'm going to go in a lighter color here, 20 inches. Be careful here. B2 looks like we have 14 inches. And then our height, we have 5 inches. So again, order of operations, looks like we want to do our grouping first. So we'd say we have this. 1/2 is still out front. 20 inches plus 14 more inches is going to give us 34 total inches in here. And we say this is 5 inches out here. Okay. So now we say, okay, well, what's left? You know, we have nothing to do in grouping. We have no exponents. From left to right, I suppose we could do our multiplication. So let's start with this. 1/2 times 34. And again, you multiply fractions straight across. If you need a little review here, this would be 34 times 1 over 2 times 1. But if you remember anything from Algebra 1, you notice that we can cross-cancel these and get a 1 here, and 2 goes into this 17 times. So we would get this. We say 17 inches times 5 inches. And one important thing to note on this one is this. Not that 5 times 10 is 50, and 5 times 7 is 35, and 50 plus 35 is 85, but more about this. Inches times inches, this is inches times itself, or inches squared. So this is some area, but we want to make sure that we're using units. Cheers.